Let's take a look at query patterns and performance in Neo4j. The Neo4j graph engine is implemented to traverse relationships very quickly. As you become more experienced with Cypher queries, you will learn that there are multiple ways to write a query that returns the same results. The difference in queries is typically its traversal performance. In this training, you will begin learning about graph traversal and query performance. A pattern is a combination of nodes and relationships that is used to traverse the graph at runtime. You can write queries that test whether a pattern exists in the graph. Here is an example. This query retrieves the anchor of the query, the Tom Hanks person node. It then follows the acted-in relationship to a movie node. Then, for the movie node and person node, it tests whether these nodes are related by the directed relationship. If they are, then the row is returned. This exists test is done for every movie node related to Tom Hanks as an actor. This query returns the single movie that Tom Hanks directed and acted in. You can use the profile keyword to show the total number of rows retrieved from the graph in the query. In the profile, you can see that the initial row is retrieved, but then 38 rows are retrieved for each movie that Tom Hanks acted in. Then the test is done for the directed relationship. This is a better way to do the same query. This is a query that you have seen before. In this query, it retrieves the anchor, the Tom Hanks person node. It then traverses all directed relationships that point to the same Tom Hanks node. This traversal is very efficient because the graph engine can take the internal relationship cardinalities into account. If you execute this query, it returns the same result as the previous query, the movie title, Larry Crown. Notice, however, that this query is much more efficient. It retrieves one row, then two rows, much less data than the first query. Note that the performance of queries that use patterns will depend upon the data model for your graph and also the number of nodes in the traversal. The difference between using explain and profile in your queries is that explain provides estimates of the query steps, where profile provides the exact steps and number of rows retrieved for the query. Providing you are simply querying the graph and not updating anything, it is fine to execute the query multiple times using profile. In fact, as part of query tuning, you should execute the query at least twice, as the first execution involves the generation of the execution plan, which is then cached. That is, the first profile of a query will always be more expensive than subsequent queries. Note that query tuning is beyond the scope of this training, but it is important to profile your queries so that you can optimize the queries of your application. The metric that is typically a good measure of query performance is the number of DB hits. You've just seen that using a pattern and testing the existence of a pattern in the graph is not optimal. This may or may not be the case depending on your data model. There is a scenario where using exists for a pattern is useful. You use not exists to exclude patterns of the graph. We want to find all the movies that Tom Hanks acted in but did not direct. Here is the best way to do this. Here we want to exclude the directed relationships to movies for Tom Hanks. If you profile this query, you will find that it is not performant, but it is not the only way to perform this query. This completes our look at Neo4j query patterns and performance.